all, this is Neil from Edureka and welcome to this interesting session on IoT architecture. Now, Internet of Things is a really big buzzword out there and each person out there has its own definition for Internet of Things, but we just have two of these which really outstand them or which we personally feel defines Internet of Things as its whole. Now, Internet of Things aims to create a world where all the devices and appliances are actually connected to a network and in turn actually collaborate with each other to complete complex tasks which requires a high degree of intelligence. The objective or the intention here is to help everyone ease up their tasks or day-to-day challenges, and this can be done using various devices that's out there using a connection as a network or a medium with respect to it. And in this case, the medium becomes the internet. Now, another definition of Internet of Things is it is an interaction between the physical and digital world using sensors and actuators for that matter. Again, when you have devices which are out there, which are around us, communicating with each other and building a smarter system, then it makes our lives much more easier for that matter. When we come down to the IoT ecosystem, there's no single consensus, or again, there's no single architectural design that's out there which is agreed universally, because each company, each organization, each user for that matter has different requirements. And when we look down to it, we can break it down to a simple three-level architecture wherein we have a perception layer where sensors actually gather the information from the environment around it. Okay, once this is done, I'm going to pass this information to the network layer. The network layer in itself takes up the responsibility of transferring this data from the sensors to the next layer, which is the application layer. Now here the main objective or the responsibility is the application in itself delivers this information to the end user or the end platform for that matter. This architecture can also be expanded to a 5-layer architecture. Now, when I talk about a 5-layer architecture, it's quite similar here itself. The difference mostly comes around with respect to the transport layer, the processing layer, and the business layer mostly here. When we had 3 layers doing the earlier task, we have just broken this down so that we have an easier operation or a smoother system for that matter. Now, again, the perception layer remains same when it gathers the information from the sensors, but the transport layer actually transports the data between the sensor to the processing center. Now, this could be through a wireless system, it could be through Bluetooth, it could be through RFID, 3G, NFC, or any medium that I choose to. Once the information has been transmitted, the processing layer comes into picture, which actually stores the relevant information, analyzes this, and again processes it as per the user's requirement. Now, again, this could employ various databases, cloud computing services, as well as big data processing modules to store this information as well as process it for that matter. Once this is done, I give the information to the application layer, which is actually responsible for delivering various services to the end user for that matter. On top of all of this stands your business layer. Now, any device for that matter, when it is working on a large scale environment, a business layer is usually used here. Now, let's say I'm working in an organization where we're using multiple pumps for different use features in different locations for that matter. A business layer here actually monitors the complete functioning of these pumps. You can also have these in various cars as well. So what I would know here is if a car is going to break down, then I also get an awareness with respect to that individual car, and it also helps me enable or helps me reach out to the closest customer care center so that it can assist the user. Coming down to how I can process it, again, this can be divided into 2 segments. I have my cloud computing based processing, wherein here it's quite simple. Once I have the information, I pass it on to the cloud platform, which then in turn also processes it and also has various applications to deal with this processed information for that matter. Now, again, this is something that I can do on a system which does not require any immediate action and requires a large amount of processing for that segment. But let's say I'm in a system where I need immediate response. In those cases, I can go with my fog computing. Now, again, fog computing is something that represents a layered approach wherein we actually insert monitoring, pre-processing, and storage with the security layer between the physical and the transport layer. Let me just go back a few slides here to help you understand this. Now, if you actually look, my fog mostly comes between these 2 layers, wherein I add 4 new layers for that matter. Now, again, this is used in order to make a system quite smarter or effective with respect to it. Now, between my physical layer and my transport layer, I have a monitoring layer, I have a pre-processing layer, a storage layer, and a security layer. Now, to help you understand this, let's take a real world example out there. Let's say I have a complete traffic system which is built on my Internet of Things. Now, let's say at one point there is an ambulance that has come to a first signal. I detect this, and what I do is that I allow the ambulance to move from this traffic signal by giving it a green light. But what you need to understand is, if I'm using a cloud computing, this message has to be passed on to the cloud. This information has to be then processed, and then correspondingly a map has also to be created. At the same time, when I use a fog approach, what happens is that all the pre-processing and the storage happens on the gateway level itself. The information from the sensor goes all the way till the gateway. Therein, it actually pre-processes this, stores the relevant information, and sends this back to the corresponding sensors as well. So let's say if there's an immediate track that I can create to the closest hospital, I would highlight all the traffic signals to be green so that the ambulance can move smoothly as well. Now, security here is very essential, because if I implement this, tomorrow anyone can actually try to manipulate this for their requirements as well. Imagine there's a high-speed police chase happening and the culprit uses this in order to move fast from the traffic signal. So this is something that is really essential. Although there is a pro to this, there's also a con, and this is how we try to overcome this issue. Now, talking about each one of these new layers, when I come to the monitoring layer, what it actually does is it monitors the power consumption. It monitors each of these resources as well as their response and the services that are running on these resources. Now, this in turn helps me monitor or gives me a complete idea of which are the services or which are the sensors which are working, where are the challenges, what is the power consumption, and how it works with respect to that same. Now, once I have information from these sensors, what you need to understand is that usually you work with thousands of sensors in a real world environment. Now, I need to understand which are the necessary information. So I'm going to do a level of filtering, I'm going to do a level of processing, and then I'm going to apply a level of analytics to understand what is needed and what is not from these information as well. Now, the temporary storage area is something that I use in case I want to store any relevant information. Let's say I'm creating a route today for an ambulance as well, and this is going to be stored in my temporary storage area. But this also needs to be used in future scenarios. So once I'm done with this usage, I can also push it on to the next transport layer, which can send it to any other storage system that is part of my environment. Now, as I said, security plays a very important role. Although my fog computing is something that makes my system faster, it should not be easily manipulatable. Now, in a cloud-based system, I have the assurance that it's not really easy to break down the security. It's quite hard, where there are various layers of security which are part of the system. But when I have a fog system, it's essential that this factor or the security which deals with the encryption, which deals with the privacy of the information, the integrity of this information is maintained. Now, there's also a very interesting variation of this which is called an edge computing system, wherein rather than doing all these operations after I have gathered this on the gateway, I can do it on the individual nodes or individual sensors as well with respect to it. So where I have edges, these becomes point for me to perform operations on the data that is being collected. So that's a slight variation of our fog computing system as such. Next, let's talk about the various taxonomy associated with Internet of Things. Now, these are the key concepts, or these are the key layers which are present with respect to most architectures that's out there. Now, as I said, this is a generic idea. Each person or each system that's out there requires its own level of customization, requires its own level of approach to solve that problem. But these always remain the fundamental layers which are included in all the architectures out there. First, we have the perception layer, which is usually the layer where we gather the information from the various sensors that's out there, or we use the various sensors which are required as part of our system. Then we have the processing layer, wherein we perform filtration, we summarize the data, we again do a level of analytics on this data before we decide to send this relevant data to the system that's above this. Now, then I have a communication layer. Now, communication layer is very simple, as in here we'll define the protocols and standards as well as the medium through which the information has to be passed from my sensors to my main system as well. Now, middleware is something that's quite essential here. What it does is that it creates an abstraction as well as it makes my system work much more smoother. Now, what you need to understand is that there are various components involved here. Middle layer really helps me integrate the information coming out from each of these sensors or each of these individual systems. Once it's present, then I can pass it on to my application layer, wherein I have various applications which help to improve the overall experience of the user as well as provide much more accuracy and efficiency to the information that's present. Now, coming down, let's talk about each layer one by one. Now, before I talk about the perception layer, what you need to understand is that one of the most important aspects of Internet of Things is context awareness. That is what you need to understand with respect to the change of environment is very important, and this is extremely impossible without the usage of sensors as such. Now, sensors in themselves are very small in size. They again cost you very little, and at the same time, they consume very little power. Again, there are various constraints with respect to the factors as the battery capacity and the ease of deployment as well, but let's not go into them as such. Now, when I talk about sensors, again, we have various types of sensors as such. One of the easiest example of sensors that can be seen on a daily basis is the sensors which are part of your mobile. You have a location sensor, you have a movement sensor. Camera in itself is actually another sensor. Your microphone, your light sensor. These are all various important aspects of your mobile that we use on a daily basis. Apart from this, neural sensors, medical sensors like the fitness bands that we use, healthcare bands which are used for heart patients, again environmental sensors which check the temperatures around the environment, make you aware of the changes, chemical or biosensors which are very useful on a daily basis as well. Again, infrared sensors are something that's quite common as well. Now, when we talk about RFID, this is something that's really important, or this is something that really gathers a lot of attention with respect to it. RFID stands for radio frequency identification. Now, unlike a traditional barcode, it does not actually require a line of sight of communication between the tag and the reader, and can identify itself from a distance without even a human intervention or a human operation for that matter. RFIDs are technically of two types. You have active and passive. Active tags actually have some amount of power source associated with it, and passive sources do not have anything related to it. And when we talk about the RFID technologies as well, there's near and far. A near RFID reader uses a coil through which we actually pass AC current and generate a magnetic field. Now, when we generate a magnetic field, anything that comes in its vicinity, it registers with respect to it. Now, when I talk about a far RFID, it basically is a dipole antenna in a reader. Now, this again propagates an electromagnetic waves, and tags themselves also have a dipole antenna. Now, again, these are something that's used in various applications that's out there. Now, one key factor which is associated with the perception layer is an actuator. Now, when I talk about an actuator, it actually is a device which can affect a change in the environment by converting any sort of energy into another. Now, this could be a motor which is generating electricity. This could be a windmill which is converting the wind outside to you to a electric form as well. Again, these are just some of the examples that's out there, and actuators themselves play a very essential role in the perception layer. Now, the next layer that we have is the pre-processing layer. But before I really talk about the pre-processing layer, let's actually try to understand the limitations of trying to process everything that we have on the cloud system, which is part of our ecosystem. Now, when I talk about this, one of the key or one of the biggest challenges for me is mobility. Let's say my sensors are on devices which are in constant motion. Then it becomes a really high challenge for me to pass this information continuously to my cloud environment. Again, this could be through the challenge of transport layer. This could also be due to the challenge of power consumption associated with it. When my smart device or when my sensors for that matter are in constant motion or are in constant mobility, then it cannot completely pass all the relevant information onto the cloud. Now, this in turn actually causes a challenge for me to have some latency. This could also lead to a latency with respect to real-time processing of the information that it gets as well. Now, if I'm working on a critical system, then real-time information is something that I highly depend on, and that becomes a challenge as well. Now, if I really want to scale up, if I want to use a lot of devices, then my cloud computing system also needs to scale. But there's always a chance to increase the latency because I'm working with multiple sensors or multiple devices that's out there. Imagine today I have a system which just includes 1,000 sensors. But let's say in a smart home system, there's close to about 10 to 20,000 sensors associated with it. So this is just one small system. Imagine if I'm trying to build a smart city. In that case, there's going to be hundreds of thousands, millions of sensors that's out there. If my cloud computing system cannot process this on a real time, then there's going to be a high challenge with respect to that say. And this is exactly where the usage of smart gateways comes into a picture. This layer actually helps me process my data on real time. It also helps me filter the data on based on the priority or the requirement, and creates a local copy of whatever is needed or whatever needs to be taken forward. Now, when I come to the pre-processing layer, or when I come to the features of fog computing for this matter, there's a very low latency because the information does not have to go to the cloud system wherein the processing needs to be taken up. It always is done on the gateway level itself. This information really is faster, as we've seen in the previous example about the ambulance. Now I can also use distributed nodes wherein the information does not have to be, or the processing has to be on one single node for that matter. When I'm using distributed nodes, then I can also distribute the effort or the work that is needed as well. When I'm on a mobile environment as well, these smart systems can communicate with the gateways present in its closest proximity. It does not have to connect to just one single gateway. If I'm setting up gateways across multiple points in my city, then it makes it quite faster and more efficient. And this in turn can also lead to a real-time response from the gateway for that matter. Once I have a real-time response, then it is making my system faster. And as in the previous example, rather than just clearing one signal, I can clear an entire path for the ambulance as such. Now, once I have relevant information, those which are necessary or those which are really something that I need to ponder or I need to analyze can be sent to the cloud system as and when as it's needed as such. So this is something that really makes my pre-processing layer important and efficient and effective. Coming to the next layer, which is the most important layer that's out there, which is my communication layer. Now, as your Internet of Things environment actually grows, this is a compromise or this is a combination of various heterogeneous devices which are connected to the internet. What you need to understand is that these devices in themselves need to pass these informations, and some of the challenges that the communication layer should actually address is with respect to, let's say, first start off with addressing and identifying of each of these informations, wherein I know which device is sending me the information, what is that device, if I want to communicate back to that device as well, how do I do that? Again, when it comes down to the communication in itself, this should also not cost me a huge amount of consumption with respect to power. Because if I save up a lot of energy with respect to how the information is gathered, but I waste a lot of energy in transmitting this information, then I don't have a smart system. Again, information itself which comes should use various routing protocols which actually require very low memory and should be very efficient for that matter. If the information itself needs to be bounced around different layers going from different segments of your ecosystem, then it needs to use very less memory. And this itself should be very fast as well as seamless for that matter. Now, when I come down to each of these components for that segment, let's talk about NFC or the near field communication. Now, NFC is actually a very short range wireless communication technology through which usually mobiles interact with each other over a distance of a few centimeters for that matter. Now, all the type of data can actually be transmitted between two NFC enabled devices in seconds by bringing them close to each other. Now, this in turn is actually based on the RFID concept, and it uses a variation of the magnetic field to communicate data between two NFC enabled devices. Now, if again we go down into slight specifications, NFC usually works on the frequency band of 13.56 megahertz, but again, this is very similar to high frequency RFID. Now, I'm not going to bore you more with respect to the technical details. We'll talk about the next segment, which is your RFID and WSN integration for smart objects. Now, again, many a times what you need to understand is that data from one single sensor is actually not useful for monitoring large areas and complex activities. Now, here what you're going to use is that you're going to use various sensor nodes to interact with each other. Again, this also has to happen wirelessly. Now, the disadvantage of a non-IP technology such as RFID, NFC, or Bluetooth is that its range is very small. So they cannot be used in many applications wherein large area needs to be monitored through many sensor nodes deployed in various locations for that matter. A WSN or a wireless sensor network consists of 10 to 1000 sensor nodes connected using a wireless technology. They collect the data about the environment and communicate it to the gateway device and relay the information to the cloud infrastructure over the internet as such. Now, when I come down to the IoT network protocol for that matter, usually what you need to understand is that the IP4 protocols themselves can only be used for communication of close to 20,000 devices. Now, again, the internet protocol used by these devices is something that's quite a challenge as well. Because when you look at it, the predicted amount of devices that's going to be available by 2020 in the Internet of Things domain is close to 40 billion. Imagine 40 billion devices communicating with each other. Now, if I don't have a smart system, or if I don't have an effective low power system, then I cannot communicate or I cannot gather the information from this. Now, usually a low power IPv6 is used for these network or these communication, which helps you in passing of information from these sensors onto your processing or onto your cloud infrastructure. Now, again, when I come down to the low energy technology, my main challenge with respect to communication is always to ensure that low energy technology is most probably used. In this segment, we have your Bluetooth low energy, which is usually referred to as a BLE, and this was actually developed by the Bluetooth Special Interest Group. Now, what you need to understand is that it actually has a shorter range for communication and consumes lower energy as compared to its computing protocol. Now, the BLE protocol stack is actually quite similar to the stack used in classic Bluetooth technology. However, it has two parts. It has a controller and it has a host as well. Now, the physical and the link layer are implemented in the controller, and the controller is typically an SoC or a system on chip with a radio for communication. Now, the functionality of the upper layers again are included in the host, and BLE is actually not compatible with classic Bluetooth. Now, the next is a low power Wi-Fi. Now, again, the Wi-Fi Alliance has recently developed a Wi-Fi Halo, which is based on your IEEE 802.11ah standards. Now, this in turn consumes very less power than compared to your standard Wi-Fi devices, also has a longer range. Now, this exactly is why it is most suitable for the Internet of Things applications for that segment. Now, any device that supports Wi-Fi also supports IP connectivity, which is very important for an IoT application for that matter. Now, the last is Zigbee. Zigbee is also based on the IEEE 802.15.4 communication protocol and is used mostly in personal area networks or PAN. Now, again, the range for Zigbee devices to communicate is very small, usually between 10 to 100 meters, and the details of the network and the application layers are also specified by Zigbee standards as such. Unlike the BLE, the network layer, which is part of the Zigbee, provides for multi-hopping routing. Now, when I come down to more details about the Zigbee network, I have three types, which is an FFD, full functional device, an RFD, reduced functional device, and one Zigbee coordinator as well. Now, with this, I just hope you have a simple understanding of how communication is essential for the Internet of Things architecture and the various ways that you can implement the communication between the devices as well. Now, the next concept or the next layer with respect to the IoT architecture is the middleware segment. Now, when I come down to the middleware, one of the key challenges or one of the key issues that comes into the picture is the interoperability as well as the program abstraction. Imagine I have 40,000 devices communicating with each other. 40,000 devices may not all use the same programming language or may not pass the information in the same way as well. I need to build or I need to have something that ensures that these devices communicate with each other and there is an abstraction maintained between the information passed from these as well. Now, if I have multiple devices also, what I need to ensure is that these devices are independently discoverable and I can manage each of them. Today, I need to be aware if one single sensor also breaks down because the information coming from the sensor is extremely important as well. When it comes down to scalability, it is extremely useful because when I need to grow my ecosystem, this middleware really comes into picture. If I can replace an existing middleware with something that can help me scale up, then I don't have to completely variate my entire ecosystem as well with respect to it. Usually, when I use a highly capable middleware, then it also lets me perform big data analytics and implement security and privacy as well. And this in turn usually helps me communicate with my cloud computing and also context detection. Now, again, when you come down to the middleware segment, you need to understand with respect to the various specifications of the application, which kind of database is it oriented, what is the semantics it's based on, what kind of events can it process, and what kind of service can it process or provide as well. These are some aspects that you need to keep in mind while you're selecting your middleware for your architecture. Now, the last layer is your application layer. Now, application is something that really is what your end user gets or is what usually maintains or helps process your information to the best that's out there. Now, this in turn can be used in different domains. It can help you achieve different things. It can help you have a smarter lifestyle. It can help you have a smarter environment. Your entire home system can be managed with respect to an application. Your car management can be done using application. You can build an entire social life and entertainment system based on a smart application. Now, although the end user usually only looks at the application layer, this actually is the front face of your entire architecture. Now, with this, I hope you at least have gotten an idea of what the entire skeleton of your IoT architecture comprises of. Now, what we've discussed here is just the skeleton. It's always up to the user to add in muscles to it and complete it with a skin as per your requirement. With this, we come to a conclusion of this session. I hope you've had a great learning experience. And if you're looking for any more interesting videos on IoT, please let us know in the comment section below. Thank you and goodbye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!